Your do now for today then. So a bit of a recap on some surds. Okay, I want you to simplify the first few, then there's a rationalize the denominator there, and then expand and simplify. You know what you're doing. Okay, you got 5 minutes. At the end of the 5 minutes, whatever you've done, obviously you need to check my marking. Not check my marking, check yours against my marking, and stop. I want you to have a go at everything. Don't just sit there and go, no, I don't get it. I want you to have a go. Even if you get it wrong, just have a go. Okay, so I'm going to start the clock now. Off you go. 3, 2, 1. Blast off. Let's go. Okay, so if we're simplifying surds, we're looking for square numbers hidden in here that I can then square root and take them outside of that square root. Now remember, 75 could be made of, if you think of what square numbers are there, well, 25 is a square number. If you times it by 3, you get 75, right? So that 25 is kind of hidden in there. Now that means if we can make 75 from 25 times 3, my surd rules mean that I can actually write that as two separate square roots times together. And because I can square root 25, that's why I was looking for the square number, I can actually write it as 5. So that's 5 lots of root 3, written as 5 root 3. Okay, now do that with both of these. 20 could be made up of 4 times 5. 4 is a square number. And, oh, that's adding, isn't it? Sorry, let's add those together. Then 45 could also be made up of 9 times 5, couldn't it? And 9 is a square number. So the 4 can be taken out of the square root, so we square root it to get 2. So that would be 2 root 5. And the 9 can be taken out and square rooted to go outside of the square root sign. So that's 3, because the square root of 9 is 3, leaving the root 5 left inside. Now remember, just like algebra, if I had 2x and 3x, I would put those together to get 5x. In this case, it's 5 root 5. Okay. Rationalize the denominator. That means get this square root from underneath. So get an actual proper number underneath the fraction line here. Now the way I can do that is if I times the bottom by root 5 and times the top by root 5, it will magically disappear. So 1 times root 5 is root 5. Root 5 times root 5. Remember, a root times by itself actually gives you the number that's in it. So it's 5. Root 5 over 5. Expand and simplify. Right, FOIL it. First, root 5 times 5, we've just said, gives you 5. Outers, so root 5 times 3 is 3 root 5, so 3 lots of root 5. Inners, 2 times root 5 is 2 lots, oh that's really bad, isn't it? 2 lots of root 5, not in a very straight line. And then lasts, 2 times 3 is 6. And then simplify what you can. 5 plus 6 is 11. 3 root 5 plus 2 root 5 is 5 root 5. Okay, 11 plus 5 root 5. You might have put 5 root 5 plus 11. That's also fine. Now these are the trickier ones. These, when you've got two things on the bottom here, if I multiply just through by root 5, sure, this will turn into 5 when I multiply it, but the 6 will just turn into 6 root 5. I will still have a square root. You need to times the bottom by what we call the conjugate. It's the same essentially, but with a different sign in the middle. And when you do that, the roots will magically disappear from underneath. Now because my question has 6 plus root 5, I'm going to times it by 6 minus root 5. But you times the top and bottom by the same thing, okay? Because that keeps my fraction equal, right? Now the top is just one lot of this, so that is fine. 6 minus root 5. Now underneath, we're going to FOIL it. 6 times 6 is 36. I've got 6 lots of root 5. I will have 6 times minus root 5, so that's minus 6 lots of root 5, which is why it's going to disappear, because they cancel out. And then root 5 times minus root 5 is minus 5, because one's positive, one's negative. Simplify that up. The top will be 6 minus root 5, and underneath, oh, that is a 5, promise. And underneath, 36, remember those cancel out, disappear. 6 take away 5. Sorry, 36 take away 5 is 31. So 6 minus root 5 over 31. Okay, right, off to the task you go.